Good morning. Dear students, in our previous lecture, we discussed about vectors, vector algebra and its types. But certain vectors remains there. So today, I am going to explain few more vectors. It is an 11th class topic. Besides it, it's very important for second semester physics students. A vector is represented by a line with an arrowhead. The line of the vector represents its magnitude, and the arrowhead, that represents its direction. Equal vectors. There are various types of vectors. We have discussed about equal vectors, negative vectors, unit vector, co-initial vector, collinear vector. Now today let's discuss about zero vector. Zero vector. If I will define zero vector, it is very simple. A vector whose magnitude is zero. In other words, it is also called a null vector. A vector whose magnitude is always equal to zero. Zero vector is insufficient in vector algebra. It has not much more significance in vector algebra. So zero vector is represented by this is 0 and this is vector. Now simple, zero vector is a vector whose magnitude is null, 0. Let's move ahead. Axial vectors. Axial vectors. Axial vectors. Very important. Those vectors whose direction is along the direction of motion of a body. Those vectors whose direction is along the direction of motion of the body. Such vectors are called axial vectors. For example, displacement vector, velocity vector, momentum vector, all are examples of axial vectors. Now, how to understand axial vectors? For example, let's have a car. Let a car is moving with a velocity of 10 meters per second towards east. If we have a car, it's moving with a velocity of 10 meters per second towards east. Now, what is the quantity here? Velocity. What is the direction of vector? What is the vector here? It's the velocity. But what is the direction of this velocity? It is towards east. That is towards east. But what is the direction of motion of this body? That's also towards east. So remember that. Those vectors whose direction is along the direction of motion of a body, means along the direction along which body is moving. Such vectors are called axial vectors. Axial vectors. Now another important point is there. Polar vectors. Polar vectors. A polar vector is just an opposite of axial vector. Why? Because axial vectors are those vectors which acts along the direction of motion of the body. Now, polar vectors, those vectors which acts along the axis of rotation. Those vectors which acts along the axis of rotation. Such vectors are called coaxial vectors. For example, let's take an example. Torque, angular momentum, linear momentum, not linear, angular momentum, angular velocity, all are examples of polar vectors. Why? Let me elaborate it. If a body is moving with some angular velocity along the direction of rotation, but in anti-clockwise direction, this is the body moving in anti-clockwise direction, but here along some axis, that's axis of rotation, xy is here axis of rotation. Now this axis is axis of rotation, axis of rotation. Now if this is omega, omega means angular velocity. Here the direction of angular velocity is along xy, but the direction of motion of the body is anti-clockwise. Anti-clockwise. This is the direction. This is the direction of motion of the body. Similarly, we have a fan. A fan has the axis, it's moving along some axis. But the vector along the axis of rotation, not along the direction of motion of body. Such vector is called polar vector. Now, two important vectors. Number first is position vector. Position vector. In order to explain position vector, we need to draw a Cartesian frame of reference. You know what's Cartesian frame of reference? A frame which gives us the position, velocity, displacement of a body. That's called Cartesian frame of reference. You know that we have many frame of reference. Rectangular coordinate system, which is called the Cartesian coordinate system. Similarly, polar coordinate system. But here I will only deal with this rectangular coordinate system. Let me draw, in order to explain position vector and displacement vector, let me draw here a Cartesian frame of reference in which I will consider two coordinate axes, x-axis and y-axis. This is x-axis, this is y-axis. Let a body is moving in xy plane. If at any instant of time t, the body is at position p1. Now after some time, let the body reach to position p2, but after a time interval of t dash. Now, if we will join the positions of this body moving in xy plane with the origin, then that line, that vector will give us the position vector. If I will join here, this is A position and this is P1 position, or of P1, and I will join of P2. Let of P1 is equal to R1 and let of P2 is equal to R2. The vectors which gives us the position of a moving particle with respect to origin, such vectors are called position vectors. In other words, those vectors which give us the position of a moving body, such vector is called position vector. Now, here of P1 is the position vector which is equal to R1. Of P2 is the position vector which is equal to R2. Now, what about displacement vector? What about displacement vector? A body was moving in xy plane. At position P, at a time t interval, it was at position P1. At a time t dash, it was at position P2. A vector which gives us the displacement of a moving particle. How much distance does this body travel while going from P1 to P2? That line will give us displacement vector. P1, P2. P1, P2. This vector, P1, P2. It is called position vector. It's called position vector. Now displacement vector. Now what's displacement vector? A vector which gives us the displacement of a moving particle. Such a vector is called displacement vector. I thought it's enough for today. Inshallah, tomorrow we will deal, as you know that vectors need vector algebra. They can be added, they can be subtracted, or they can be multiplied only by using vector algebra. So, remember that tomorrow we will deal with addition, subtraction, and multiplication of vectors. And I have already told you that we can't use vector algebra for the division operation on vectors because vectors have direction. One more thing is clear. Whenever you understand vector, direction is very important. If I will say 2 meters, it is a scalar. But if I will say 2 meters towards east, it is a vector. It is a vector. So always deal with vectors, but take necessary steps about direction. So that's enough for today. Press the bell icon and subscribe our channel, Baba Academy of Learning.